and design of bituminous pavements. So this session is actually arranged to clarify some of your queries regarding all the topics that we have covered so far in this NPTEL course. Okay. We had a couple of questions in the form that we have forwarded earlier. So I think some of the participants are there live now, so they can ask. You can unmute and switch on your video, and you can ask your queries. Okay, so we'll start the session. I think Mr. Rohit is here. Rohit, if you have the, I think you have posted one question. So if you can ask, you can just unmute and ask your question. Rohit, are you there? You're muted. Yeah, I think he can unmute. So the question, so I'll read out his question. How tire pressure or contact pressure affect bursting of tire? That was the question, I suppose. Padma ma'am, will you be answering that question?
Yeah. Generally the tire bursting happens when the tire is weak or when the tire pressure is too high. But in such kind of a scenario, we don't consider a contact pressure and tire pressure to be same. Means that kind of a scenario does not exist for the design here. Okay. So if you can elaborate on a question, what exactly you want, we can add more to that.
Rohit, can you just elaborate the question? Because what you have asked is, how is contact pressure related to bursting of tire, right? So that doesn't have a direct connection of like contact pressure and bursting of tire. Okay, please do. He has mentioned this type. So.
How bursting can be avoided on CC or bituminous pavement? I don't think bursting is related to the type of pavement here or pavement cross sections, anything. It is more to do with the tire conditions and the tire pressure inside.
Maybe you can add on what context you are mentioning about tire bursting. Is it because of high tire pressures? And maybe if you can unmute and talk, it would be better. Like it would help us to understand what you're exactly looking for.
मैम गुड मॉर्निंग मैम।
Good morning.
मैम अभी रिसेंटली बॉम्बे हाई कोर्ट ने एक स्टेटमेंट दिया है कि टायर बस्ट इज नॉट एन एक्ट ऑफ गॉड बट एन एक्ट ऑफ ह्यूमन नेग्लिजेंस। तो इससे हम क्या रिलेट कर सकते हैं, मतलब कि जैसे टायर प्रेशर जो हमारा है वो टायर प्रेशर लो होना चाहिए या हाई होना चाहिए ड्यूरिंग हम स्पीड में जैसे चलते हैं, तो उसके अकॉर्डिंग टायर प्रेशर का क्या रोल है?
Okay, Padma Nivita, should I?
Yeah.
Okay, what he has mentioned is that the High Court has given a verdict saying that this tire burst is not an act of God, so people have something to do with it. So whether we should have a high tire pressure or a low tire pressure to avoid bursting, when you are riding. So that is the question. Yeah.
Neetu, you'll answer?
Yeah, see Rohit, there are specifications which says that okay, this much should be the tire pressure, right? It has no direct connection with the type of the pavement. Okay, whatever be the pavement you have, so there has to be certain tire pressure that is to be maintained by the vehicles. Okay, and the contact pressure is something. See, depending upon the tire pressure and the load that is coming, your contact pressure will be different on the pavement surface. So we will be interested in looking at what is the contact pressure that is acting. So for convenience of analysis, because different vehicles having different loads will be exerting different contact pressure on the surface, right? So for the sake of convenience, we assume a constant contact pressure for the design, okay, because we can't find out what exactly is the contact pressure that is exerted by all the type of vehicles on the pavement surface, right? So if you are discussing about the design of an analysis of pavement structure, the direct bursting of tire has nothing to do with in that, but definitely yes, there are certain amount of pressure that is to be maintained. It shouldn't be too high or too low. See, the people adjust their tire pressures in order to improve their efficiency or the loading capacity of the trucks, right? So that is something this truck vendor, the truck manufacturers or the truck people are actually doing. So that shouldn't be done. So that is, I think that is the scenario under which this particular verdict has come. Okay, so that is not directly related to the design of payment systems. I hope I answered your question. Padma, would you want to add something? Or?
No, this is correct. Like the tire pressure does not do anything directly with here the payment type or payment design.
आप समझ के जो we were trying to tell or Rohit, is it fine? If there are any other questions from the participants who have joined late, so if you have any questions, you can please type it in the chat box, or we would prefer you to unmute and ask the question.
There is a question from question in the link provided. Shall we read that and answer now, Neetu?
Yes, ma'am.
Maybe after this candidate joins, if they ask it, we will repeat again.
Yeah, hopefully that person has joined who has asked a question. Which question you are? Which question is it, ma'am?
We have two more questions other than contact pressure.
Yes.
Just one. We will make it.
Yeah, please. Shall I read it?
Yeah.
This was a question from Mr. Lakshmi Narayan. I think, I don't know, maybe Lakshmi Narayanan R. So the question was, in IIT PAVE, when we are providing the combined thickness of bituminous layer and for granular layer, further after getting the strain conditions to be satisfied with respect to performance models, how do we split the exact thickness of BC and DBM in case of bituminous layer and WMM and GSP in case of granular layers? This is first part of the question, and the second is further to the split thickness. How? Yeah, please answer.
Take this first part.
Yes, miss.
Yeah, actually, we are in the 9th week on IRC design based on IIT PAVE. It is in the following week. So anyhow, you have a demo of IIT PAVE software related to this in the coming week. Now, related to the question asked, in a Ken PAVE or in an IIT PAVE, we consider two similar layers to be a single layer. For example, you have a BC layer and a DBM layer as a bituminous concrete layer, means a bituminous mixture layer. So BC layer and DBM layer, if the modulus value of these two layers are the same, or all material properties are same, we consider it to be a single layer, and we do calculate the tensile strain at the bottom of a bituminous concrete layer, or at the bottom of the first layer. So in such conditions, if both layers are different, how do we account this both layers in this IIT PAVE software? This is the question first. So you can consider in such case, instead of a single layer, you can count it as a two layers and give the modulus value, respective modulus value and respective Poisson's ratio value and the corresponding thickness. For example, if a BC layer is of a thickness 40 millimeter and DBM of thickness 60 millimeter, a combined thickness of 100 millimeter, you can separate into a two layers of 40 millimeter and the corresponding modulus and Poisson's ratio values are taken. And DBM 60 millimeter, the corresponding modulus and Poisson's ratio values are taken. So what IIT PAVE software will do is, it will assume both layers to be bonded. Each means its IIT PAVE software is on an assumption that all layers are bonded layers. So it will assume both layers are bonded, and the critical tensile strain at the bottom of a DBM layer will be used for calculations of the fatigue damage. So, Nivita, you want to add anything, Nivita?
No, this is fine. See, it is not possible to take it as one layer and then later split it into the BC and DBM part. So in such a case, what we have to do is initially itself consider them as two layers. Take a BC layer, use its thickness. Obviously, since you're using a denser gradation and higher bitumen content, there will be a slight difference in modulus between the BC and DBM layer. So in that case, we could use appropriate modulus for BC, appropriate modulus for DBM, and compute the strain. But here, again, since the critical strain, one of the tensile strain is calculated at the bottom of the bituminous layer, we'll be only doing it at the bottom of DBM layer and not for BC layer. Okay, so the critical strain, though we take two bituminous layers, critical strain will be computed only at the bottom of DBM layer. Similarly, your granular layers, if we are using 5 layers as in a conventional pavement, BC, DBM, granular base, granular subbase and subgrade, and if you want to incorporate these 5 layers into design, it is better to consider them as 5 individual layers, analyze them as 5 individual layers in IIT PAVE, use their appropriate thickness, Poisson's ratio, and compute the critical strains. But using them as one layer and later splitting into 2 different type of layers may not be possible. For a given layer, we can have 2 lift thickness. Lift thickness as in the sense when I'm constructing, if I have 200 mm bituminous, say for example, 200 mm bituminous layer, my paver may not have the capacity to pave the entire 200 mm in one go. In that case, what I could do is do 100 mm first, 100 mm second. Okay, this is called as lift thickness, the thickness that I use for construction. So that in that case, you can assume them as one layer during design. But if there are two different type of mixes, then you have to consider them individually during the design stage itself.
See, and one more thing is, if you for a base course or means as a sub base course, if both are granular layer, see the modulus value, the resilient modulus value, what we use is also pressure dependent, or it also dependent on the depth. So if you want to consider a different modulus for different layers, so based on the depth, you can use it as an individual layer, and the two layers, interface between the two layers will be considered as a bonded layer for the analysis purpose.
Okay, I think that explains that first part of the question, and second is also part is also related to this. Further to the split thickness, how to check if it is adequate in design. That is, for example, how to provide resilient modulus for DBM and BC separately in the parameters.
Okay, see, IRC 37 gives some indicative number of resilient modulus. For example, if you use a BG40 bitumen, you have at 35 degrees Celsius indicative number table to be like around 3000 megapascal. But if it is an indicative number or number which is determined in the laboratory, whichever is lower. So you follow an ASTM standard to determine the resilient modulus value. You get the value and use the resilient modulus value in the corresponding layers here. So you consider a separate resilient modulus value for BC and for DBM. And you do the analysis, compute the tensile strain at the bottom of a DBM layer, and use that in the computation of a fatigue damage distress.
Okay, and the last part is, in case of hot wrap being involved in the project, what are the aspects that could be considered in the design? Or are there specifications to work in IIT PAVE for the layer with wrap?
See, the wrap here, hot wrap here, it is IRC specification means gives the specifications of usage of wrap in a base course. Okay, so like if you use a wrap in a base course, it is treated as a granular material. So you compute the modulus of a granular material, but again there is a specifications restricted to specification related to the modulus of a base course. If you use a wrap stabilized base course, there is a maximum limitation for the modulus here, like we use 800 megapascal, or you can do a laboratory test and check your modulus value, but it is considered as a granular layer. Okay. So when you use a wrap material in a granular layer, in a base course, you can consider it to be a granular layer and you do the design. In case if you use a wrap on a bituminous layer, again you need a modulus computations, but there is no such indicative numbers given in an IRC 37 here. Amita, want to add?
Yeah, so there's nothing specific that explicitly wrap could be considered in design in IIT PAVE. The only thing is you can whether you're using it as a base, like what Padma ma'am said, you can use it as a in the base layer and consider it to behave as a granular material, or use it in a bituminous layer. Accordingly, you have to determine the modulus and use the corresponding modulus for your design. Okay, that is the only thing when you use wrap. All other things are outside the design perspective, like how much proportion of wrap to use and what method you use to measure the modulus, how it is measured. So all that is another part. Okay, so once you determine all these things, as far as design is considered, the only difference that will be here is the change in modulus. Apart from that, there is no special consideration in IIT PAVE in the design procedure.
So the input directly goes for the design is only the modulus and Poisson's ratio of the material here. So if you have any new material, you can compute the modulus value and give that. Means you can determine the modulus value in the laboratory and see to that whether that is meeting out the IRC specifications and use it in the design.
Ma'am, I have a comment or concern in this. Just as you mentioned that there is no like modulus value, the input consideration given for hot trap in IRC. So, I mean, for hot trap, we know with the amount of recycling, we may get as high as 4,000, even up to like 4,500, 5,000 MPa. But again, given that IRC 37 doesn't give the modulus values for hot trap, so we are still restricted to using 3,000 MPa, right? I mean, because there is no IRC given that allows me to use even 4,500 MPa if I'm recycling, say, 60% and getting like 4,500 MPa.
Yes, there is an IRC specifications which states that use the modulus computed from the laboratory or 3000 megapascal, whichever is lesser. So this is the conventional design that we do it based on IIT specification. But if you are interested in, always you can give a try of what exact modulus, giving the exact modulus value and getting the thickness. But if you design following an IRC 37, the specification states that use the laboratory determined number or 3000, whichever is lesser.
Yes, ma'am. Yes, ma'am. Yeah.
Essentially, there is. Can I add one more thing? Well, essentially, this cut for this or this restriction for this modulus is to cater for the fatigue performance as well. Because if you give a very high modulus value material, so there is every chance that this material can fail in fatigue also. So you have to consider the rutting as well as the fatigue response. If the performance allows you or the such a high RAP content ensures that the performance is fine in rutting and fatigue damage, then you can go with a higher modulus and try out, right? As Padmama mentioned, even though IRC has this cap of value, so in your field trials, maybe you can try that.
Thank you, ma'am. I have just another thing to ask in this aspect. Say when we are going for, say, 3-layer DBM system, so for the perpetual pavement. So in the 3-layer system, as Padma ma'am had mentioned, we could use the wrap either as, as a granular layer or as a part of the, normal DBM layer. So in that 3-layer, if I say I'm talking of the perpetual system, so is it possible that I can use the bottom DBM layer as part of the either if I use wrap material, say a cold mix, or maybe a cold mix, hot mix, or in between a cold or hot mix. So will that layer be treated as a part of the bituminous layer of the perpetual system? Or will it be the bottommost layer? Or will it be considered as a part of the granular layer?
No, you have to add one more question, one more detail to this. Do you want to design following IRC 37 or you are asking like how do we proceed this?
Yeah, I'm thinking out of the box, out of the gamut of IRC 37. Yeah.
Okay. Yeah. Okay. See, perpetual payment, like it is something like you restrict the strain value to a minimum. Okay, if you take a strain at the bottom of a DBM layer, IRC defines a perpetual payment to be when the strain is less than 80 microstrain. Okay, and strain on the rutting to be less than 150 microstrain. Okay, so if you see hot mix asphalt is typically a viscoelastic material and it is not a granular layer. So even with the wrap, hot mix asphalt, depending on the proportion you use it, how much proportion you use it. So the behavior, whether it is a granular, whether it is showing a granular behavior or viscoelastic behavior, again, it depends on the proportion of wrap we are adding it. So you can determine the modulus value. Depending on the proportion, you consider it to be either a granular layer or a elastic layer. We don't use a viscoelastic assumption here.
Okay.
So we consider it to be an elastic layer and we give a resilient modulus value. So you can compute the means a DBM material with the wrap. Depending on the proportions, the behavior is going to vary. Depending on the proportion of wrap, the behavior is going to vary. Okay. So again, there are many things other than whether you are using a wrap in the DBM. DBM means the many factors controls whether it has to be considered as a granular layer or as a bituminous layer. So one such factor is a percentage of wrap that we use. Okay. So IRC 37 specifications allows only wrap to be used only in the granular base. Nita, want to add?
Okay.
No, I think this is fine. It depends on basically the kind of binding that we have. So if I add in my cold mix, if I add like an emulsion or a foamed bitumen, along with it, usually we add cement to have this binding. So when I add all these things to wrap, then it kind of behaves something similar to but you can consider it to behave like a bituminous layer. But whereas you don't have all these binding agents, you just use a very small proportion of an emulsion or something like that, then maybe you can treat it as a granular layer. So it depends on how we design the mix.
Sure. Okay. Thank you, ma'am.
Are there any other questions, or shall I read out the questions in the form?
There is one more question, Nonita.
Yeah, yes, there was a question. Rutting happened due to compressive strain at subgrade layer. How would the rut resistant BT layer will reduce the rutting? Padma ma'am, shall I answer this?
Yeah.
That question was from.
It was from
Mr. R. Srinivasan.
Yeah.
I think he has not joined. Okay, see, IRC 37 suggests that you look at the subgrade rutting alone. Okay, so if you limit the strain or the compressive strain on top of the subgrade, such that your subgrade rutting is restricted. So your rutting equation essentially tell you how much number of repetitions it can take so that the subgrade rutting doesn't happen. Okay, but it doesn't mean that every other layer does not rut, because all these are like the first top one is a bituminous mixture laid and compacted to say 7 or 6 to 7% air voids, and you have the granular layers. So due to loading, there is every possibility that each one of these layers will have certain amount of permanent deformation or rutting, right? But what you say is that if you limit the lower layer, that is the subgrade, where the strain that happens at the subgrade, then every other layer, the rutting will be under control. So that is the assumption. And one more thing is that, see, the top bituminous layer, the BT layer, as you say, if you want it to be, there is no deformations on that top layer, because that is a layer which is more prone to rutting because the stresses are the highest at that top surface, right? So what it mentions that you use a rut resistant mixture. That is, you work with your mix design, your use of better quality materials, stiffer binders, and so on, so that you can make this top layer as rut resistant layer. Okay. So it was not mentioned. I think that the confusion was that if you make that as a rut resistant layer, it doesn't ensure that you don't have subgrade rutting. So that is not the point. You are designing your pavement structure, the different the layer thicknesses, in such a way that the subgrade strain is limited, okay, which ensure that all the layers will have minimum rutting, or the rutting well within the limits. So the other point was related only to the top bituminous layer. To prevent its own rutting, it is better to go for better mixes having rut resistance. So that was the whole point. I think the person who asked the question is not here. Hope the others understood it. But ma'am, is it fine, or you want to add?
Yeah, it's fine. So all the point over providing a rut resistant layer as a bituminous top layer of a bituminous layer as rut resistant is to avoid a rutting in a bituminous layer. Subgrade layer, like the rutting in a subgrade layer is governed by a compressive strain at the top of a subgrade layer. So if the modulus of a top layer increases, it influences the rutting in the subgrade layer. But the point of providing a rut resistant layer at the top surface is to reduce the asphalt layer rutting.
Yes. Are there any other questions? Yeah, there is a new question here in this. Mr. Vijay Raghavan has posted the question. I think, give me 1 second.
Where, Neetu?
In that forum, there is a new question posted now. Okay. A dual carriageway 4-lane highway with AADT of 4,000 commercial vehicles per day in the design direction has 2 categories of trucks A and B, having truck factor 2.54 and 3.62 respectively. The percentage of trucks A and B in the stream are 60% and 40% respectively. If the growth factor of both trucks is 6%, the design traffic for a period of 20 years is okay. I think this was our assignment question. So I suppose you want to know about like how did we arrive at this answer? Probably. So I will just explain, because you have 2 categories of trucks. The total truck traffic is given as 4,000 commercial vehicles per day, and it is in the design direction. So your directional distribution factor is 1 only. So you have like 4,000 vehicles. Then you have 2 categories, like one is A and B with 60% and 40%. So if I divide it, 60% of 4,000, it's like 2,400 vehicles is truck A and 1,600 vehicles is truck B. Okay. Now you're given the truck factor for each of these classes. So suppose I want to convert it into its equivalent standard axle loads. I just have to multiply that number of vehicles into its truck factor. So I'll multiply 2,400 with its truck factor, which is 2.54. Then 1,600 with its truck factor, which is 3.62. So 2,400 into 2.54 plus 1,600 into 3.62 will give me the total equivalent standard axle loads. So I have converted the total 4,000 to e-cells. Now what you have to do is that you have to project it for 20 years. Okay. Now how do we do that? It is 1 plus r raised to n minus 1 by r, where r is the growth factor, which is which is given as 6%. So it is 1.06 raised to 20 minus 1 by 0.06. So that will be the growth factor. You can multiply it with the growth factor, and also 365 because this is per day. So that will give you the million standard axles. I hope that is clear now. Or if you still have any query, you can, I think Mr. Srinivasan has given the preferable time as 6 to 9 p.m. So probably he's not, he's a working professional, so he's not joined today. But if you have still any further queries, you can put it in the forum, and or you can email too. Okay. Now I don't see any more questions in the chat box. In that
there is a question in the message box.
In the chat box.
Suppose there is 5 CBR values on a project, length 8, 10, 12, 14 and 15. At which CBR value we have to design a pavement? Okay, it all depends on what is the traffic volume here. See, what you can do is you can compute the percentile CBR here. Like if it is a 90%, if we take a 90% CBR, if the traffic is more than 10 MSA, or we take 80% CBR when the traffic is, when the traffic is more than 10 MSA, yeah, we go for 90% CBR. When the traffic is less, you can even prefer to use 80th percentile CBR. It's a percentile, so you need to compute the percentile here. So for computation of a percentile, what you can do is you can find out the cumulative CBR value and compute the 90th percentile, which indicates that 90% of your CBR value is less than that design value. So 90th percentile is considered as a design CBR, and you can take that CBR and compute the resilient modulus value and use that in the design. And again, it is an effective CBR. It is not just directly the CBR. If the subgrade has a multiple layer, say for example, one layer may have a CBR of 8%, other layer may have a CBR of 15%. So it is the effective CBR that we use it in the design. So that effective CBR computations that we have it in the 10th week.
Okay, there is a request whether we can make a video on this. So
It is
I
already
think
there. Okay. It's already there.
yeah, it is there in the 10th week. Okay. So are there any other questions?
The same person has added, there is no video for load spectrum in detailed.
Load spectrum means what? I didn't get that. Can you elaborate on what exactly you mean? What load spectrum you are referring to? Mr. Muzammil Ahmad, yes. I can unmute and talk.
Yeah, good morning, ma'am. Ma'am, my question is load spectrum. There's I think load spectrum for single axle, there's a 80 to 90, 90 to 100, and for the tandem axles, there's a gap 110 to 130, 140 to 160, and
Yes.
for the tridem there's a 30 kilonewton gap. So like
Yes.
that, I don't see any video in detail. So how can we analyze that load spectrum, repetition of the load axles and frequency?
So essentially this load spectra or the load axle load spectrum will depend from highway to highway, right? So if you want to design for a particular highway, you need to find the axle load spectrum of that particular region, either a similar highway or the existing highway. So wherein when you do the axle load survey, you will come to know like what is the highest level of loading that is there and to the lowest level. So you'll get the spectrum. So you need to do an axle load survey. So from the axle load survey, if you see that, say for example, your single axle single wheel is in the range of say 40 to 100 kilonewton. So what you do is that you divide it into 40 to 50, 50 to 60 and so on. You can divide it into 10 kilonewton load groups and put the frequency in that. So in the fifth lecture, we have shown an Excel sheet wherein the data that is collected from one of the highways is shown there, and how we have divided into different axle load groups and the frequencies and how it is converted to an equivalent single axle loads is shown there. So in order to get that, you need to do an axle load survey. So, sir, is that the question? Did I
Yes,
answer
ma'am. That is my
Okay.
question. But ma'am, that was not in so much detail. That's why I'm saying.
Okay. We do.
In that video, I just feel that you just touch that topic, and just after touching you move on another topic. That's why I feel that.
No, sir. In the fifth lecture, actually, we have shown the Excel sheet. The Excel sheet of like if I have the axle load data, how I convert it into the equivalent standard axles and the design traffic. How you reach at the design traffic? Either you can use a truck factor method or you can use a vehicle damage factor. Vehicle damage factor essentially means you will find one equivalency factor for the all type of trucks. Whereas in truck factor, for each class of truck, you will find an equivalency factor. So for both these, I have explained it in week 5. So you please have a look at it. Otherwise, you can always email me, then I can explain in detail. I hope the idea is clear to you now.
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Thank you so much. Ma'am, one more question. Ma'am, suppose, ma'am, this course is very good. There's no doubt. But ma'am, right now, what is happening in India? There is so many MNCs who is asking for the experience in UK design and Astro design. But ma'am, can you provide the course on DMRB course and Astro course and Australian course?
See, you have a 12th week lecture and half of a 11th week lecture by Professor Murli sir, covering other standard codes. Okay. So you wait till 12 weeks to complete, and maybe we will be organizing another live sessions. If you have any doubt related to that, after seeing the video, you can ask.
Yeah, there is a question here whether there will be another Zoom session after completing all the 12 weeks. Yes, sure. If there is a demand, then definitely we will have a session. So since some of you have joined, Greena, will we be collecting the attendance for this meeting, or can you just share a form, Greena or Catherine?
Hello.
Yes, sir.
Yes.
Assalamu alaikum by Arabic language. Good morning by English. This, I think, one student from outside India, Abdullah Adam. I'm not preparing my question for this session, but I need to thank all professors for all lectures and all information getting in this 9 weeks, and we wait for other 3 weeks. I'm very, very thankful for that. Really, I need this course in this time because I'm working developing guideline for our pavement structural design in Saudi Arabia. Yes, I'm Sudan, but I'm working in Saudi Arabia. Maybe I have one question about the climate model for Professor Nafisa. I think this is correct. Nafisa?
Nivita.
Navita, yes, okay. I can use this climate model separately, and where I can get this model, because you say this inbuilt in Ashware. Thank you. Yes. Sorry, I am not prepared because every week I send my questions through the discussion group. Thank you. And I hope join IIT Madras in future as a PhD student. Thank you.
Yeah, thank you, sir, for your question. We'll be having one more session on climate and the other topics before the end of, maybe we are planning 2 more live sessions, one on climate and the other topics, and one at the end of the course. So maybe you can prepare your questions and during the next session. But to answer your question regarding the EICM model, it is inbuilt in the Ashtaware software. Okay, all the models that I have mentioned in the climate, your CRREL model, CMS model, infiltration damage, these are all equations which are inbuilt into the Ashtaware software. You can take the concept, you can mimic, but we have to program it. Okay, the equations are all given in the MEPDG manual. So when I say model, it is nothing but like you take certain input parameters, use it in that, and compute what would be the temperature at this point in the pavement, or what would be the moisture content at a given depth in a granular layer. So these are the things that we would be getting as outputs from the model. So the equations corresponding to all these calculations, all the detailed equations are given in the MEPDG manual. Okay. So we can program it, but we have to create our own. If you want to mimic that without using the Ashtover software, then we have to develop our own program to make all these calculations. But apart from that, the module is not available separately. It is only inbuilt into the Ashtover software. But one advantage here is you can create your own climate data file. Say, for example, for India, as of now, I think for about 18 locations or so, we have created a climate data file which you can input in the Ashtover software. Okay, so given all the other things, I can use my climate data for which all these things, the EICM model will calculate all the other things and give me the output. So it is our realistic climate data that we would be using through this Ashtover software. But the thing is, you have to have access to Ashtover software, which is a licensed software. Second thing is, we have to create the climate data file, which requires some amount of homework. It took us at least 3 to 6 months of a learning time to see how it is integrated and how to create, how to develop that climate data based creation using a program. So this took us some time. Because Ashtover requires it in a specific manner. You have one space extra, that climate data file will not be accepted. It will say as invalid file. Okay, so that could be done initially. You just use our climate data, create a file and incorporate it in Ashtover software. Otherwise, we can use those equations given in the manual and create your own model. That is also fine.
Madam, how more this CanPave and IIT Pave softwares are important in this subject, madam? CanPave and IIT Pave, it is very useful in the future also.
Sir, your question is whether it is useful in the future. That was the question, because we couldn't hear it properly.
Yes, sir, it is applicable for designing. It's a very important one for CanPave and IIT Pave. In IRC 37 is there that
Yes.
IIT. Tell me.
Yes.
Shall I answer?
Yeah.
See, previous version of IRC, in the previous versions of IRC, you had a design charts, and you don't need to compute the stresses and strain at a critical locations. You can just pick the thickness based on the design equations. But the current IRC designs are based on results obtained from the IIT PAVE software. So if you are looking for the design of pavement, the critical stresses and strain should come from the software. Okay, or you need to do a manual computations if the number of layers are if the numbers are layers are more than one, like 3-layered, 5-layered structures, manual computations becomes very tedious here. So we get the critical stresses and strain from the software and use it for the design here. So the design cannot be made without a CanPave or IIT PAVE software here. So okay.
And to add to that, sir, see, IRC 37 has given you some catalogs, okay? Like in the previous, it has given you some typical cross sections for different classes of categories of payments, but you can use that only for low volume roads or for less unimportant highways, because for the major highways and all, you definitely have to do the design using IIT PAVE itself. If it is not available and for unimportant, less important roads, you can use that the cross sections that are given in the catalog. That is what IRC says.
So those catalogs are for a specific input, like specific modulus and thickness. So those catalogs may not be applicable for all the designs. It is applicable only for the material that has this modulus and thickness. Okay. There is one question in the chat box. Can we design a cement treated base without a standard axial load repetitions? This is like, so now if you have a pavement cross section with a cement treated base, okay, see the top layer is bituminous concrete layer, and you have a cement treated base, and above a cement treated base. So to arrest the crack, you have a crack preventing layer or a crack relief layer, and below that you have a subbase course. A subbase course can be a granular or a cement treated subbase, and this is resting on a subgrade. So you have a 4 or a 5 layered structure. Now if you have this 4 or a 5 layered structure, we design the pavement for different distresses. So one distress is a fatigue damage in a HMA layer, and the second distress is a compressive strain or a subgrade retting, and third distress is related to a cement treated base. So you have an additional distress, means cement treated base distress to be computed in addition to the fatigue damage on the HMA layer and rutting on the subgrade layer. So see, the fatigue damage on a HMA layer and a rutting on the subgrade layer, the distress equations are calibrated for a standard axial load with a standard pressure of 560 kilopascal. So when you design a HMA layer or subgrade rutting, we use a standard axial load. For a purpose of cement treated base design, see if it is an IRC method approach, which recommends to use an ASTRO design guidelines, means ASTRO equation for computing a damage in the cement treated base. So that again depends on the individual axial load and not based on the standard axial load. So we compute a cumulative damage on a cement treated base based on an individual axial load. So you need an axial load that is acting, and number of repetitions of that particular axial load group, and we use that in the design of damage, means damage related design on the cement treated base. So you have a separate video on this in the coming week, that is on the design of pavement cross section with a cement treated base. So you can refer to that video. So I hope we answered Varun's question. Yeah, thank you. So there is also one more question on the chat box, post related to rigid pavement design.
One more question is there.
Chat
Now,
box.
whether the chat box, whether the design of inverted pavement is same as that of conventional flexible design.
So is this inverted pavement means that a flexible overlay over a rigid slab.
This one.
Okay. See,
Right.
IRC 37
Same here.
specifications for an overlay design is applicable only if you have a base course or sub base course as a granular layer. Okay, if your base course is of a cement treated or a rigid base, like we cannot use this IRC method of pavement design there.
So we don't see any more questions in the chat box. So there is a feedback form that is posted in the chat box. All of you have joined. Please fill that up. Questions here. Some other question. There is a question in the chat box. When we design the pavement with geotextile, there is a need for improvement factor. That improvement factor provided by whom, and we use that in IIT pave. Do we use that in IIT pave? Maybe that is a question. Aman, you want to answer?
Yeah. What is that improvement factor provided by whom?
I understand that the question is, when you have to use a geotextile, where will you get this improvement factor from, and how do you incorporate it in IITP? So I think that was the question. Geotextile as a so can you elaborate whether geotextile as a separator layer or it's a use of geotextile in the subgrade, or so what is this question related to? Sir, can you please elaborate?
There is an IRC specification related to this improvement factor. I guess it is IRC SP59. Okay, so it gives you the modulus improvement factor related to a geotextile, if you provide a geotextile layer. So IRC SP59, you can refer to IRC SP59 for the estimation of a moduli value of a subgrade modulus in case if you have a subgrade provided with the geotextile. And so that improved, even IRC 37 specification gives this, mention this as in a reference. Okay, so the improvement factor can be obtained from that IRC SP59. And use that improved modulus in a IIT paid software in a place where you have a subgrade modulus.
Can we, since there are no more questions, it's 11. So can we wind up the session for today and then have more live sessions if it is needed in the later stage?
Okay, ma'am.
Ma'am, am I audible?
Yeah.
Yes.
Ma'am, I have another question. Whenever we go for a stabilized base below the asphalt concrete, the critical tensile strains that we are observing in IITPO output is under compression. What does that indicate?
No, can you please repeat your question?
Ma'am, like whenever we go with a stabilized base below the asphalt concrete, the critical strains that we are observing in IITPO output is under compression, ma'am. We are not getting in tension. So what does that indicate?
No. Yeah, I see critical strain at the bottom of HML layer, you are meaning, right?
Yeah.
Okay. See, there are, I don't know which strain you are looking at. There are 3 different strains, right? 3 different normal strains. One corresponds to sigma Z, sigma T, and sigma R.
Yeah, yes, ma'am.
So is that the negative value in IIT pay represents compression? Like which strain are you looking at?
Yeah, ma'am, in that sigma T and sigma R only we are getting negative symbol.
See, if you get it negative, I don't know for what is the input you have given, but if you get it in a negative value, it means the tensile strain at that layer is zero.
Like this, that stabilized base, if we give the modulus value of 4,000, around 4,000, then we are getting compression. Or else if we give a 9,000 means, then we will get in tension only.
Stabilized base of 9,000 input is not allowed.
Not 9,000, ma'am, 4,000.
Yeah, 4,000. 4,000 and what is the modulus?
What? Sorry, ma'am.
What is the modulus?
HMA thickness around 100, ma'am.
Okay.
Modulus is 3,000.
Okay. Can you check once your IIT output?
Ma'am, actually we checked it many times, but we are getting in compression only because the stabilized base layer is stronger, no, ma'am. So it acts as an inverted pavement here.
One second, I have a IIT page software. So can you tell your input?
Once again, ma'am, I don't have input. I'll just go.
You also use your crack relief layer, right?
Yes, Sammy, ma'am.
Okay.
Yeah. Ma'am, actually, the asphalt layer thickness is 40 layer. 40 layer.
Or if you don't have it now, maybe second time when we meet, you can give the data. We can discuss on that.
Yeah, sure, ma'am.
We will anyway be planning one more session in the coming week. So you can keep your data ready, or you can share it before itself with all of us. We'll have a look at it and like try to suggest what is happening there during the next session.
Yeah, sure, ma'am. Thank you, ma'am.
Shall we wind up then?
Yeah.
Okay, so thank you all for joining this live session. Hope you are closely following all the week sessions and you are submitting your assignments. So we will have one more session at the end after 12 weeks, or as Nimita said, in the coming week, so that we will plan and let you know. So we'll wind up today's session. So I request all of you to please fill up the feedback form also. So thank you all. Have a nice day.
Thank you.